Hi, welcome back. We're going to take a look at some second derivatives now. Now the second derivative does get a little bit more complicated for us. So let's go ahead and start here. Now notice the notation. The 2's here tell me we're looking for the second derivative. We talked about the notation in an earlier video, so go back and watch that if you want to. So here we're given the circle x squared plus y squared is 25. So if I start taking that derivative, we're going to get 2x plus 2y dy dx equal to 0. So if I solve for dy dx, we're going to get negative 2x over 2y. I can write this as just negative x over y. And that's where the fun begins. Because now I have to take the second derivative. There's my first derivative. Now I have to take the second derivative. And the problem with the second derivative is we're going to have to use the quotient rule on this one. That's going to give us low times the derivative of the top, which is just negative 1, minus the top. The top is negative x, so I can make that a plus x, times the derivative of the bottom, dy dx. That's where our trouble begins, over the bottom squared. So there's our second derivative. I am just going to rewrite this. This just becomes negative y plus x dy dx over y squared. Now I'm about to show you something really cool. This is actually a complex fraction. But if you notice this dy dx, this should look familiar. It's just our derivative. I can replace this dy dx with just my derivative. But there's another way we could do it that makes it a little bit easier for us sometimes. And that's this. I just need to multiply by my LCD. That's that dx. I can multiply by that, top and bottom. And I distribute. If I distribute to the first one, we're going to get negative y dx plus distribute here, the dx's cancel, and I'm left with x dy. On the bottom, we get this y squared dx. Now, we can't leave it like this because we don't like to have dx, dy like these in our equation, so I'm going to replace them. But I know something. From my derivative, I know that dy is negative x. And I know that dx is y. I can replace those. So what am I going to get? Negative y dx, which is just y, plus x and dy, which is negative x, over y squared times dx, and dx again is just y. So if I simplify this, I'm going to get negative y squared minus x squared over y cubed. And I can leave it like this. There's my answer. I can leave it like that. Or I can factor out a negative 1. And watch what happens when I do that. I get y squared plus x squared over y cubed. And you might be like, yo, why are you doing that, Teach? Well, take a look here. What is y squared plus x squared equal to? Just 25. So this top here is just 25. So it's just negative 25 over y cubed. And there's our answer. They pretty much always work out this way very nicely that way. They're nice. All right. Try number 5. I'm going to go on to, number 5 is in the same way. I'm going to move on to the next note. We want to find all points that are horizontal. All right. What's so nice about implicits is the dy dx. So horizontal is telling us that our slope, which is the derivative, has to equal 0. So I have to take my derivative here. So that's going to give me what? 6x squared plus, be careful, there's my implicit, 2y dy dx. And that's just going to equal 0 right there. Solving for dy dx, we get negative 6x squared over 2y. I can leave it like this, but here's some really cool things for us. Here's something really cool. To get the horizontal, and I can see that here, where my slope is horizontal, I only have to find where the change in y is 0. So think of a horizontal line. The change in y is 0. It's not going up or down. If we look at our horizontal lines here, they're not going up or down. So for the horizontal, we can just say that dy has to equal 0. In other words, we're only looking at the top. Same way for a vertical. Well, for a vertical line, my change in x will be 0. There's my vertical line. There's no change in my x values. So we can say that dx is 0. We only have to look at the bottom. Right there. So if I'm looking for a horizontal, I only have to look at the bottom. Sorry, the top. dy equals 0. So dy here is just negative 6x squared. That's what's so nice about this Leibniz notation. And if you solve that, you're going to get x equals 0. But they do want us to find the points here. So now I have to plug that in. So in other words, I have to find y. That's going to become 2 times 0 cubed plus y squared is 3. And if you notice, we're going to get two answers. Y is plus or minus root 3. And we should get two answers, because look at our graph. We have 2 points where there's a horizontal tangent right there. So they're going to be 0, root 3, 0, negative root 3. And there's our two answers. Very easy to do. All right, for number 7. For number 7, we're dealing with vertical tangents. So we're going to take our derivative, find dy dx, and then find all points where there's a vertical tangent. Remember, points means x and y. So I take my derivative, 4y cubed, be careful, dy dx, there's a y there, that's just 0, equals to 2y dy dx plus 2x. Get your dy dx's together, so I got to bring this over. So that's going to become 4y cubed dy dx minus 2y dy dx equal 2x. Factor out your dy dx. 4y cubed, sorry about that, 4y cubed minus 2y equals 2x. And let's see what we get here. dy dx equals 2x over 4y cubed minus 2y. Wow, take a break from that derivative. That was kind of a nasty one. Next, to find the vertical, we set dx equal to 0. That's the bottom. That's this 4y cubed minus 2y equal to 0. And I can factor this, okay? This is going to become, if I were to factor this, we get out 2y, and that becomes 2y squared minus 1 equal to 0. So we're going to get y equals 0. And weirdly enough, we get two answers, plus or minus square root of 1/2. Wow. So we can get three answers here. So when we go to find our points, we now have to find x. We're going to do a few of them. The first one, y is 0. If I plug 0 in here, we're going to get 0 plus 1 equals 0 plus x squared. Notice x becomes plus or minus 1. Wow, we have a lot of points here. We get 1, 0 and negative 1, 0. So there's our first 2 points. Next, we've got to do plus or minus the square root of 1. So y equals the square root of 1/2. Sorry, not 1, but 1/2. Plugging this in. Let me zoom out here just a little bit so we can see. Plugging this in, we're going to get the square root of 1/2 to the 4th plus 1 equal to the square root of 1/2 squared plus x squared. All right, well, let's see what happens here when we do this. When you square the square root of 1/2, we're going to get 1/2. We're squaring that again, we get 1/4. Plus 1, that's just 1/2 plus x squared. Solving this, use common denominators here. This is 1/4 plus 4 over 4 minus 1/2. If I multiply here, 2 over 4 equal to x squared. What do we get here? 5 3/4 equals x squared, and we get plus or minus the square root of 3/4. So our other point would be the square root of 1/2 plus or minus root 3 over 4. Now, by luck, because these are even powers, if I plug in my negative root 1/2, they're all going to become positive anyways. So we're also going to get negative square root of 1/2 plus or minus root 3/4. So let's count that. 1, 2, 3, 4, 5, 6 points on this one. You won't have one like that bad on a test or quiz, I hope not. If they do, run, just run, save yourself. I will see you all later. Hope you enjoy the videos. Bye-bye.